Let me give you a second pop quiz that also has to do with risk, but a different kind. So we're going to play a game. And the game involves the prototypical urn example that was probably the bane of your existence if you ever took an undergraduate statistics class. Imagine a big urn that's got 100 balls in it. 50 of them are red, 50 of them are black, but the urn is opaque, so you can't see inside it. And you and I are going to play a game. I'm going to ask you to write down on a piece of paper your favorite color, red or black. And I'm going to draw a ball out of the urn. And if I draw the ball of your color, I'm going to pay you $10,000. But if I don't, then I'm going to pay you nothing. All right? And you're going to get to play this game with me exactly once. And the question that I have for you is twofold. One, which color would you prefer for the game? Any preference? No preference? Really? They're absolutely the same, except for color. Same shape, same weight. Everything is the same but the color. So, any preference? You know that the right answer is no, but I bet you all have a preference. So come on, spit it out. What is it? Red. Yeah, red, that's right. So it turns out that in the general population, there's a slight preference for red over black. It's okay, you can admit it. But mathematically, it doesn't matter because it's 50 red balls, 50 black balls, 50-50, right? All right, now, harder question. How much would you pay me to play this game exactly once? Now, you may not want to play at all. Remember, the prize is $10,000 in cash if it's your color, and it's nothing if it is not your color. So by a show of hands, how many people would be willing to play this game with me for $1? Okay. I wish I could play for real, but I don't have the $10,000. $1,000. How many people play this game for $1,000? $2,000. $3,000. $4,000. $49.99. $5,010. Okay. So you've got the right answer. The expected value is about $5,000, right? And most of you would probably need a little bit of an inducement to be willing to play. Those of you who are willing to pay exactly $5,000, that's often called risk neutrality, or your hedge fund manager for sure. But most of us don't like risk, so we need a little bit of a sweetener. So maybe for $4,000 you'll play because the expected value is $5,000, you pay $4,000, you get a little bit of extra, okay? Now let me ask you about a second game. This game is exactly like the first, except now I'm using a different urn. Urn B also has 100 balls, but in this case, I'm not going to tell you what the proportion is. I can guarantee you there are at most two colors, red and or black. But it could be 100% black, or 100% red, or 50-50, or anything in between. I get to choose the proportion. And you and I were going to play this game exactly once. So again, my two questions. What color would you prefer? What color do you think you'd want in this case? Red. Red? Still? Black. Why do you say black?
Because we know that most people will choose red.
You now know, it's not really most, but it's slightly more than 50%. Yeah, there's a bias in red. So you know that, so you're going to pick black. Why are you going to do that? Because you think that I might disadvantage you and put all black balls in the urn, right? Because I know that too. But wait a minute. I know that you know that. So don't you think that I might anticipate that you might do that and therefore put all red just to take advantage of that? On the other hand, you know that I know you know that. And I know you know that. And so if we go back ad infinitum or ad nauseum, we end up with, in this case, 50-50. Despite the fact that I have not listed any mathematical distribution, you can prove that in this case, it is 50-50. Now, how much would you pay to play this game with me exactly once? How many people would be willing to pay $1 to play this with me once? $1,000, $2,000, $3,000, 4,000. 49.99. 5,010. Okay. Now, the gentleman in the back, you were willing to pay $5,000 for the first, but you were not willing to pay the same for the second. Why not? Behind.
The first one I knew definitely it was a 50-50.
Yeah.
The unknown aspect makes it harder or bigger risk.
Yeah. It makes it harder. You said it's a bigger risk. And that is the common perception. In fact, the way that people put this is that there's uncertainty about the risk. And so they don't want to play. Or they won't pay as much in order to play. And the reason that this is an interesting phenomenon is that mathematically, this actually has the identical risk. Now, we can debate that, and many philosophers have debated that, but I'm going to cut short that debate and just prove to you once and for all that this has the exact same odds as the previous case. You know how I'm going to prove it to you? I'm going to ask you to pick your color by taking out a coin from your pocket and flipping it, and if it's tails, pick red, and if it's heads, pick black. In other words, you randomize your choice. There is no possible way I could pick a distribution that disadvantages you, because neither you nor I know what you're going to pick in that case. And when I explain this to people, they understand. And then when I ask them, do they want to play this game with me with the same price as the previous one? They'll say, no, thank you. I don't feel like it. Because it's not a logical decision. It's an emotional one. Humans are hardwired to flee from uncertainty even more than risk. And what I mean by uncertainty is the unknown unknowns. In other words, I don't know the distribution here. I'm not comfortable with that. And that's a very important aspect to keep in mind, particularly in biomedicine. People don't like risk, but they absolutely hate uncertainty. And so when we think about what's going on in the biomedical field, we have to ask ourselves, how much certainty do we have? And do breakthroughs, perhaps in some cases, create uncertainty on top of risk?